Hey everyone, welcome to today's Science Bulletin. Earth's core is a scorching iron ball, with temperatures close to the sun's surface. Its radius is roughly 1,200 kilometers, about the size of Pluto. A new study suggests Earth's inner core isn't fixed in place. Based on seismic and nuclear test data, the core rotated 0.1 degrees between 1969 and 1971, and then between 1971 and 1974, it rotated 0.29 degrees. That means over those 6 years, 69 to 74, the inner core reversed its direction of rotation. These observations contradict models of a stable inner core rotation, as well as models where it rotates faster. This study marks the first time direct observation has been used to confirm the inner core oscillation model. The cycle period is roughly 6 years. Over the past few decades, the length of a day has fluctuated pretty consistently. So this study supports the idea that inner core oscillation may be linked to changes in day length. The research was published on June 10, 2022 in Science Advances. NASA's $10 billion James Webb Space Telescope was struck by a micrometeorite. This is the 5th time it's been hit. The first 4 were within the expected range, but this one exceeded it. The impact on the primary mirror was also larger than before. Researchers say the impact was an unavoidable random event, not a daily occurrence, but it'll happen regularly. These strikes will gradually and gracefully degrade the telescope's performance. So what exactly hit it? Without knowing the exact speed, it's hard to estimate the size, and so the identity of the impactor is unknown. Scientists estimate, though, it was at most a speck of dust, not a rock. Issues like impacts and cosmic rays were already factored in during the design phase. Webb also has a capability other telescopes don't. It can adjust its mirror segments to micrometer level precision. If something gets knocked out of alignment, they can just fix it. So there's no need to panic. Small stuff. This impact hasn't changed the original schedule. It won't affect the July 12, 2022 release of its first full-color images and spectral data. We've long assumed Jupiter's outer shell has convection, like boiling water. So all the elements should be thoroughly mixed together. But a new study shows Jupiter's gas envelope isn't uniformly distributed. Its interior holds more metals than its exterior. Metal abundance decreases as you move outward through the layers. This amounts to 11 to 30 Earth masses, making up 3 to 9% of Jupiter's total mass. The research was published on June 8, 2022 in Astronomy and Astrophysics. We've only been seeing the most superficial layer of Jupiter. All those stunning storm images we've seen, they're just the thinnest outer skin, only 50 kilometers thick. The real secrets of how this gas giant formed and evolved are buried deep in the atmosphere. This study provides the most comprehensive and diverse interior models of Jupiter to date, which can be used to study how heavy elements are distributed through its outer shell and how Jupiter evolved. Quick note, metal abundance, or metals here, doesn't mean what we normally call metals. In this context, it refers to all elements other than hydrogen and helium. Fast radio bursts are high-energy, ultra-brief radio pulses. The energy is extreme. What gets released in a single second equals years of the sun's output. China's FAST telescope detected a highly active repeating fast radio burst, and the paper was published in Science. This source first burst in May of 2019. By 2020, other telescopes had pinpointed its location. Then, optical observations from the Subaru telescope showed it's 3 billion light-years away, on the outskirts of a dwarf galaxy. They also found that between bursts, it continuously emits weaker radio waves. That's clearly different from what we'd seen before. So does it matter whether bursts repeat or not? Astronomers think there could be 2 completely different mechanisms at play. Or the source of a fast radio burst may behave differently at different stages of its evolution. We still don't know exactly how fast radio bursts form, but the leading candidate is a neutron star. This particular burst may be surrounded by dense material ejected during the neutron star's evolution, and as that material disperses, the signal's dispersion measure would also drop. So repeated bursting may actually be a sign of a young fast radio burst, one that becomes less frequent as it ages. June 8, 2022. Nature magazine published a paper. Scientists say they've discovered a new particle, or rather, a previously undetectable quantum excitation. It's the magnetic counterpart to the Higgs boson, which defines mass. It's been 10 years since the Higgs boson was detected. Observing a new particle usually requires extreme conditions, like the Large Hadron Collider, but this was done in a benchtop experiment at room temperature. What's wild is that a significant part of the work was done by an undergrad student. The research is also interdisciplinary, covering optics, chemistry, physics, material science, and more. That's it for today's Science Bulletin. Thanks for watching. See you next time.